Very good morning to everyone. Myself Y. Simhachalam. I am from ECU C section. Today my seminar topic is ergodic process. Introduction to the ergodic process. An ergodic process is a type of statistical process in which time averages are equal to ensemble averages. In simple terms, observing one sample of the process over a long time with the same results as observing many samples at one instance. Meaning of ergodicity. Ergodicity means that the statistical properties of a process it can be determined from a single realization over a time if it ensures that process is time invariant in its statistical behavior. Classifications of random process. Random processes are generally classified into two types. One is stationary and non-stationary. Second one is ergodic and non-ergodic. Ergodicity is a special property often applied to the stationary process. Stationary versus ergodicity process. A stationary process has statistical parameters. Statistical parameters means mean, variance, autocorrelation function, constant over time. These statistical parameters are constant over not changing in time. An ergodic process is a stationary process where time averages are equal to ensemble averages. Mathematical representation of ergodic process. An x of t be a random process. This process is ergodic if mean m t tends to infinity 1 by t integration x of t dt is equal to expectation of x of t. For mean, for autocorrelation, limit t tends to infinity 1 by t integration of x of t into x of t minus tau d tau equal to expectation of x of t into expectation of t plus x of t plus tau for autocorrelation function. Types of ergodic process. There are three types. First one, main ergodic process. Second one, autocorrelation ergodic process. Third one, cross correlation ergodic process. In main ergodic process, time average of mean equal to ensemble mean. For autocorrelation ergodic process, time average of autocorrelation function equals to ensemble averages. Third one, cross correlation ergodic process. Time average of cross correlation function equals to the ensemble average. Mean ergodicity. A process x of t is mean x of, for example, a process x of t is mean. Ergodicity of a time average mean equals to the ensemble mean. Mathematical from limit t tends to infinity 1 by t integration x of t dt equal, equal to expectation of x of t. This means that observing one signal over time given the same mean as multiple signals. Autocorrelation ergodicity. A process is autocorrelation ergodic if limit t tends to infinity 1 by t x of t integration of x of t into x of t plus tau d tau equals to expectation of x of t into expectation of x of t plus tau. This ensures the time correlation matches the ensemble correlation. Cross correlation ergodicity. The process is cross correlation ergodic if limit t tends to infinity 1 by t integration x of t into y of t plus tau d tau equals to expectation of x of t into y of t plus tau. This ensures the time correlation matches the ensemble correlation. Importance of ergodic process. First one, simplifies analysis of random signals, helps in signal processing and communications, use it to model noise and other stochastic behaviors. Fourth one, reduce the need for multiple realizations. Ergodic theorem. Ergodic theorem states that for ergodic process, Time average converts into ensemble average. This is a fundamental concept in probability and stochastic process. The theorem that acts as ergodic process is called ergodic theorem. The examples of ergodic process. First one, white noise process, zero mean, constant power. Second one, set and Markov process. Third one, random binary signals with equal probability. Fourth one, stationary Gaussian process. Non-ergodic process. In non-ergodic process, the time average and ensemble averages are not equal. For example, a random process with time varying mean or variance, such process cannot be analyzed using single realization. Applications of ergodic process. Applications of ergodic process, communication systems for noise modulation, control systems, signal processing, statistical mechanisms, reliability and queuing theory. For signal processing, this is one of the most common applications when you are analyze the signal audio clips, a radio signal or sensor data. You are typically assuming the signal is ergodic or not. This assumption allows you can calculate the average power, frequency, content, and other statistical from one recording, trusting it represents the signal, its overall behavior. For statistical mechanisms, the ergodic hypotenuse is at the field. It is the assumption that justifies statistical mechanism is the first place if you need to explain. For diffusion, we smoke for a cigarette, it will evenly spread out, fill an entire room. For thermal equilibrium, why a block of metal will evenly reach in uniform temperature. For economical and finance. Many trading and financial models be like implicity and assuming the ergodicity when they use historical data and time averages to predict the probability range of outcomes. Example, for a traders to invest a trade by using the signal image of the signal is called ergodicity economics, exploring what happens if time assumes does not hold or not. Probability theory. Ergodicity is crucial for analyzing Markov chains, which are modeled to use describe the sequence coherently, but the probability for next event depends only on the current state. This happen applications in everything is for predicting a weather pattern or to modeling language. Finally, advantages of ergodicity. The primary advantages of ergodicity is the simplification. It provides a powerful and practical structure for analyzing the complete system. First one, reduce the data needs. In many real-world scenarios, we cannot create thousands of parallel universes to get a ensemble average. For example, in economical, we only have one history of stock market. In signal processing, we have only one recorded signal. Make problems solvable. The ergodic hypothesis allows us to assume the properties we measure for our signal long observation, the time averages, are the true statistical properties of underlying system called ensemble average. Connect the micro and Markov. In physics is the conceptual bridge to connect the behavior of individual particles microphone dynamics to stable, measurable properties we see like temperature and pressure microphonic properties. And conclusion of this topic, ergodic process simplifies the study of a random phenomena by allowing the time averages to represent ensemble behavior. They are crucial and analyzing stationary random process in engineering and science. Thank you.